Hello friends, I am Dr. Shailesh Kaushal, Department of Management, Faculty of Management Studies, University of Lucknow, Lucknow. Today I am going to discuss the topic correlation. In this lecture, we will learn what is correlation, types of correlation, and how to study the correlation. So there are many methods. We will discuss only three: scatter diagram, Carl Pearson coefficient of correlation, Spearman's rank correlation coefficient. The term correlation refers to the statistical relationship between two or more variables. It means we may have two or more variable x1, x2, x3, and so on, indicating the extent to which they are associated, these variables associated to each other or change together. It means if one variable increase, the other variable also increase or decrease. So it signifies the degree to which two variables are linearly related. So it's a linear relationship between the two variables. And this also linear relationship. This relationship not linear between the two variable. It is non-linear relationship between the two variables. So it signifies the degree to which two variables are linearly related, meaning they tend to move in a similar pattern. It means if we increase the variable, if we see increase in variable x, so variable y also increase. If decrease in variable x, so decrease in variable y. So they move in a similar pattern. Correlation, basically we denote through the correlation coefficient. So correlation coefficient tell us whether the relationship between two variable is strongly positive or strongly negative. So the measure of correlation called the correlation coefficient, and the notation of the correlation coefficient, that is small r. Through this we can find out the relationship between the two variable, and for example the value is 0.9. The relationship between two variable, that is 0.9. It's a highly positive correlation between the two variables. So the degree of relationship is expressed by the coefficient, this coefficient, which range from -1 to +1. So it's a range, this value 0, -1 and +1. So correlation will vary from -1 to +1. If -1 R value, if R value -1, so it is perfectly negative correlation between the two variable. If R equal to +1, it is perfectly positive correlation between the two variable. While R equal to 0, it means there is no relationship between the two variables. The direction of change is indicated by sign. So our correlation may be negative and correlation may be positive. So through sign, we can say whether the two variables positively related or inversely related. So this sign, positive or negative sign, tell us whether the two variables positively related or negatively related. The correlation analysis enable us to have an idea about the degree and the direction of the relationship between two variables under the study. Degree means magnitude. If value of r near to 0, like plus 0.1, is it clear, or plus 0.2, so it is a low degree of correlation. If it is minus 0.1 and minus 0.2, it is low degree of correlation. So in a correlation, the sign will tell us whether the two variable positively or negatively related to each other. Correlation is a statistical tool that helps to measure and analyze the degree of relationship between two variables. Basically, it's a statistical tool. So we can check whether the two variables highly related, moderate related, or low related. It may be positive and negative both. Correlation analysis deals with the association. Basically, we are trying to identify the association between two or more variable. Association. We are not emphasizing here the one variable influencing the other, but we are just trying to check whether two variable associated to each other or not. So correlation basically tell us the association between two or more variables. Now here there are two terms, correlation and other is causation. Correlation tell us the association between the two variables, and causation tell us the cause and effect relationship, like in a simple regression analysis. So here in a causation, we want to know whether this x1 independent variable significantly influencing the dependent variable or not, like y dependent variable and advertising expenses independent variable. So we know there is a positive correlation between the two. When we increase the advertising expenses, sales also increase. So in a causation, we want to find out the cause and effect relationship, while in a correlation, it is simply association between the two variables. Correlation denotes the interdependency among the variables for correlated two phenomena. Two phenomena may be the height and weight of the students. It is essential that two very phenomena should have cause and effect relationship, and if such relationship does not exist, then the two phenomena cannot be correlated, because theory says initial years, when the height increases, weight also increases. Weight and height, as height increases, weight also increases. If this theory uh, says there is no relationship, so we cannot say there is a correlation between the two variables. If two variables vary in such a way that movement in one are more accompanied by movement in other, these variables are called cause and effect relationship. As I told you, in advertising, expenses and sales. Advertising expenses and sales, as advertising expenses increases, why dependent variable sales also increases. It is cause and effect relationship, basically cause and effect relationship. Causation always implies correlation. Is it clear? But correlation does not necessarily implies causation. If there is a causation between the two variables, there should be correlation. But it is not necessary. If correlation, then the causation is necessary. For causation, we always says there is a correlation between the two variables. It may be positive, it may be negative. So correlation basically tell us only association between necessary, but it doesn't tell the cause and effect relationship. Now, types of correlation. The types of correlation, the type 1, correlation may be positive and as well as negative correlation. Positive correlation means when you increase the one variable, the other variable also increase. Negative correlation means when you increase one variable, then decrease in the other. This is negative correlation. This is positive correlation. So correlation may be positive and negative. Positive correlation is said to be positive correlation if the values of two variables changing with the same direction. Same direction. Same direction. If we are increasing this value, this y also increase. If we decrease the x, y also decrease. So in a correlation, if the values of the two variables changing with the same direction, it means it may be upward direction and downward. When you decrease one variable, other variable also decrease. When you increase one variable, other variable also increase. Example, advertising expenses and sales. And another example, height and weight. Okay. So as your height increase, your weight also increase. In a negative correlation, the correlation is said to be negative correlation when the values of the variables change with opposite direction. Opposite direction means when you increase the price of the commodity, okay, price. If you increase the price, if price is low, for example, 5 rupees, 10 rupees, 15 rupees, 20 rupees, and sales 10 units, 20 units, 30 units, 40 units. If price is low, this 5 rupees, there may be possibility that you can sell 40 units. But when you increase the price 5 to 10, your sale will decline. So this is opposite direction or inverse relationship between the two variables. The example is price and quantity demand. If you increase the price, your sales will decrease. The direction of the correlation. Positive relationship variables change in the same direction. X increase, Y increase. Okay. X decrease, Y decrease. Is it clear? As example, height increase, so weight also increase. Height increase, then weight also increase. So there is a positive relationship between the two variables. Negative, when you increase the one variable, decrease in other variable. Like TV time increases, grades decreases. If a student watch more TV, then performance may be declined. So there is a negative or opposite direction of the two variables. Now the types of correlation, the type 2. In a correlation may be simple or bivariate correlation or multiple correlation. The multiple correlation again divided into two parts. One is partial correlation and total correlation. Bivariate means there are two variables. There are two variables like y and x, two variables. Multiple means x1 plus x2 plus x3. Is it clear? So there is a we can divide correlation into two parts. Now the types of correlation, type 2, the simple or bivariate correlation. Correlation problem, there are only two variables are studies. This is known as simple or bivariate correlation. And a multiple correlation we studies more than two variables. If we study, here we are taking 1, 2, 3, 4, 5. So there are five variables. Correlation, basically, if we understand the concept of correlation, how the concept of correlation emerges, if we see the variance. Okay, variance, the formula of variance means when we take only one variable, x bar and square, and divided by n minus 1. And the covariance means when we take two variables, we can write variance xi minus x bar into xi minus x bar and divided by n minus 1. In a covariance, there are two variables. So xi minus x bar into y minus y bar and divided by n minus 1. So correlation basically is standard form of covariance. So correlation basically covariance x, y and the standard deviation x, I and x, y. So basically it is correlation. Correlation nothing but covariance. But here covariance value may be 20, 40, 50, 100, 1000. But correlation, it is standard form of covariance. Its value varies from -1 to +1. Then the partial correlation. Partial correlation, again, it is type of the multiple correlation, or in a partial correlation help determine the relationship between two variables. Here in this multiple regression equation, there are many independent variables. I am taking only three, beta 2, x3 and epsilon. So here more than two variables. So partial correlation help determine the relationship between two variables. If I want to check the relationship between y and x, then I will control the other variables. While controlling for the influence of the third variables, then we can check the impact only this variable, how much this variable contribute to this dependent variable. For example, it can reveal the correlation between study hours and exam score. Here I am taking two variable, studied hours and exam. So here study in this example, the hours and study hours and exam score. Exam score. We know if we devote more time to study, exam score may be high. While accounting for prior academic performance, this helps us isolate the direct relationship between the two variables of interest, making it useful in various fields like education, weather detection, and more. Here we are controlling the impact of prior academic performance. We are measuring only the study hours and exam. When we control the third variable, then we can estimate the partial correlation between the two variables. Another term in a multiple correlation, that is total correlation. The total correlation, also known as multi-information or redundancy, quantifies the overall dependence among multiple random variables going beyond pairwise relationships. It measures the extent to which knowing some variables provide information about the others in a set. Through this example, we can understand the for predicting the weather. If you know the temperature, humidity, and wind speed, you can likely predict the chance of rain better than if you only know one of these factors. Is it clear? So, here the multi information, through this information, we can predict whether the chance of rain or not. Now the bivariate correlation. Bivariate correlation simply the correlation between the two variables. Bivariate means two. We are taking only two variables, so we can estimate the bivariate correlation through the product Pearson's product moment correlation coefficient and Spearman's rho. So there are two methods to check the bivariate correlation between the two variable. And other example you can see here, the Pearson correlation coefficient, that is parametric. And if you are applying the Pearson correlation coefficient, means you want to find out the value of R for two variable, whether the value will be positive or negative. So it will depend on the types of data. Data means if both the variables x and y are increasing, then there is a positive correlation between the two variables. If one variable increase and another is decrease, so there is a inverse relationship. If you want to apply the Pearson correlation coefficient, so it is parametric test, and we know that in a parametric test there are some assumptions. Both variables should be continuous. So basically there are two types of variables. One is categorical variable and another continuous variable. Categorical means nominal and ordinal, and continuous means interval type data and another ratio type data. So it is parametric, and we know that for parametric test there are some assumptions of the parametric test. The first assumption of a parametric test, the variables, both the variables should be continuous. Means we should collect data either interval scale, the continuous interval scale, or ratio scale. And second is the data should be normally distributed. Data should be normally distributed. If both the conditions satisfied, then we can apply Pearson correlation coefficient and we can find out the relationship between the two variables. So it is prerequisite that our data should be continuous, means either interval or ratio scale. Normally distributed means the normal curve should be in a bell shape. So if it is bell shape, then it is okay. Our data should not be skewed, like this is positive skewness and this is the negative skewness. This is positive skewness and this one is negative skewness. So how will we check whether my data normally distributed or not? So first of all, we should check. There are many methods to check the normality of the data. One is through graphs. We can check through value of skewness and kurtosis. If its value near to 0 or -1 to +1, so there is no issue of the skewness and kurtosis. And third is KS test or Shapiro test. So here p value should be greater than 0.05, means non-significant. If it is non-significant p value, then our data normally distributed. So before applying the Pearson correlation coefficient, we should check whether both the assumptions fulfill or not. Second is the Spearman correlation coefficient. It is non-parametric. If my data not normally distributed, it is not necessary always our data, whether data may be interval or data may be continuous, but it is not necessary your continuous data always normally distributed. Sometimes it is not normally distributed. Then what will we do? So we will convert our data into ordinal. If my data in a interval scale and data not normally distributed, then this I will apply the Spearman's correlation coefficient, which is non-parametric, and in this case both the variables should be in a ordinal level. Then we can apply the Spearman correlation coefficient. Another bivariate correlation, that is Kendall-Tau's. Kendall-Tau's, again it is ranking data, ordinal data, but here tie. When the two cases, for example, in a interviewer taking the interview of 10 students, there are three interviewer, 1, 2 and 3. For the participants, the one interviewer given the rank to this student 8, another interviewer also given the 8 rank, so it is tied score. So this means that if you rank all of the score and many scores have the same rank, then Kendall-Tau should be used instead of Spearman's coefficient. All the result will be same. You can apply either Spearman or Kendall-Tau, but if your data ties, then we should use the Kendall-Tau method, which is again non-parametric. It is appropriate for a small data set with large number of the tied ranks. The Kendall-Tau's condition, we have two variables. Both the variables should be ordinal, because my data not normally distributed. That is why I'm using Kendall-Tau, and the sum data tied. Now the another concept in the biserial and point biserial correlation. These correlation coefficients are used when one of the two variables is dichotomous, means two categories, male, female. It is categorical with only two categories. Both variables should be ordinal, means the one is continuous and one variable here, one variable should be ordinal. Ordinal means the categorical. So there may be two category. and another variable should be continuous, means interval or ratio type data. The point biserial coefficient correlation is used when one variable is discrete dichotomy, means dead or alive, categorical. So we can apply partial correlation. And biserial correlation coefficient used when one variable is continuous dichotomy, like passing or failing an exam. It is not mutually exclusive. It is continuous dichotomy. It cannot be calculated through SPSS. Through SPSS software, we cannot calculate the biserial correlation. For more detail, you can go through the book here and Anderson book, which is very good book. So I want to show you the book. Here, for more detail, you can go through this chapter. The book name is Discovering of Statistics Using IBM SPSS, and chapter name is Correlation. So here you can understand the concept of the correlation. Again, I'm recapitalizing is variance means when we analyze only one variable. Here you can see the one variable variance, and then when we uh, do or take two variables x and y, then it is covariance. Covariance basically correlation, standard form of covariance, this is correlation. And you can standard, so this is our standard form of correlation. And square root of variance known as standard deviation. So I'm talking about the point biserial and partial correlation. So you can, for more detail, you can go through this book, semi-partial correlation and partial correlation. Okay. So I come to the point. Third, the correlation, that is correlation type 2 correlation may be linear and correlation may be non-linear. What does it mean, the correlation linear and non-linear? If we see the relationship between the two variable in a like this, it is linear, it is linear, it is linear, but non-linear maybe the this is non-linear, this is non-linear relationship, non-linear relationship. So correlation may be linear and non-linear both. In a correlation, linear correlation is said to be linear when the amount of change in one variable tends to be a constant ratio in the amount of change in the other. For example, there are two variables x and y. So this is my equation. So if you can see here, the x value 1, 2, 3, 4, 5, 6, 7, 8. And here value 5, 7, 9, and 11, 13. This is scatter diagram, 15, and this. So this is your linear relationship. If you put uh, 2 into 1, so what will be the value? Value will 5. If you put 2 into 2, the value will be 7. So it's a straight line. Basically, it's a straight line between the two variables. So it is linear relationship. Non-linear relationship, the correlation would be non-linear if the amount of change in one variable does not bear a constant ratio to the amount of change in the one variable. For example, if you are taking the health and medicine, if you take in a prescribed medicine, then your health will improve. But if you take more medicine, so your health uh, may be worse. So it may be this. So it's a non-linear relationship between the two variables. Then methods of the studying the correlation. So we will study scatter diagram method, Karl Pearson method, and Spearman rank correlation coefficient. So first of all, we will study the scatter diagram method. Scatter diagram method basically is a graph of observed plotted points where each point represent the values of x and y. So there are in a graph there are two lines x and y. It portrays the relationship between these two variables graphically. So here you can see the relationship between two variables, the height and weight. The height of the student, that is 5 feet, and weight may be the 50 kg. If height is 5 feet 6 inch, the weight may be 60. So there is a positive correlation or linear relationship between the two variables. So we can show the results of the two variables through scatter diagram. So there is a positive correlation between the two variables. Next, high degree of positive correlation. So if the variables, if observations near to this straight line, so it is high degree of correlation, who will tell us the range of the variable from this point to this and this to this. So it is 0.8 means high degree of positive correlation between the two variables, same as the moderate. Here the dispersion is more compared to the previous. Here more dispersion or data more heterogeneous. That is why this is a positive correlation, low degree of or a moderate degree of positive correlation we can say. Here the negative perfectly correlation, the exam score and watching TV per week. So if you watch more TV, naturally your exam performance may be less. So there is a perfect negative correlation. And the another example, TV watching per week and exam score. So it is a negative, moderate degree or high negative correlation. Then here -2 are equal to, so it is low degree of correlation. And another, no correlation between the two variable. If you increase this variable, IQ level will not related to height. If your height is 5 feet 8 inch, there is no relationship with IQ. You cannot say more height, more IQ. The the height, if your height less 5 feet 6 inch, then your IQ may be high. It is not necessary if someone height is 6 feet, his IQ level high. So there is no relationship between the two variables. So here the example, here you can see degree of correlation. There is a positive correlation, moderate and small correlation, and low correlation. So advantage of scatter diagram, simple and non-mathematical methods, not influenced by size of extreme item, and first step is investing the relationship between two variables. So here I am taking the example First of all, we will draw this example through scatter plot and then SPSS, how to analyze scatter diagram through SPSS software. So here the example is there are two variable advertising expenses in thousand and sales in lakhs. So we have 10 observations and we want to know whether the relationship between the two, the positive or negative correlation between the two variables. So here in this example we have two variables. One is, now you can see, the variable x and another variable y. So sales dependent variable and advertising expense is this. Now the value, so here I am taking the value 10, 20 advertising expenses, 30, 40, 50, 60, 70 and 80 and another 90. Same as here, the value is the 40, 50, 60, 70, 80 and 90. So the first observation in this example, 39 more or less, x is 39 and y 47. So our point is this. Second observation, 65 and the 53, it is more or less here. And the third, 62 and 62 and 90. So 62 and 90, this is here. 62 and 58. So 58 this. And the 90, the fourth variable, 90 and 86. 90 and 86. Then the 82 and 62. 82 and this. Then 75 and 68. 75 or 68 more or less here. So here you can see there is a this is the range. It's a low or we can say high degree of positive correlation between the two variables. So how to analyze through SPSS software we will learn here. The I am performing the SPSS. This is my data set. I think it is visible, the data set here, the observations, advertising expenses, and second the sales. So how to uh, perform the scatter plot? Go to graphs and chart builder and then OK. Then we will select the scatter diagram. We select scatter diagram. There are many scatter diagrams: simple scatter diagram, grouped scatter diagram, simple 3D scatter diagram. We need only simple scatter diagram. Double click, double click, double click, and then there are two variable advertising expenses here in x-axis. Sales depend on advertising expenses, and then the clause here, and then OK, and after OK we will get the output. This is my output. We can see here the output. This is output. So there is a positive correlation as you increase the advertising expenses. So here you can see there is a this. If you draw the line, so most of the observations, so it is moderate positive correlation between the two. And here you can draw the line. The line is double click. When you double click it, then this and then clause. Now you can see there is a positive correlation between the two variables. So we can represent our data through scatter plot. Now we will take the another case study in Carl Pearson coefficient and Spearman. Okay. Now we take the Carl Pearson coefficient in next lecture.